Okay, problem number 42 on 3.3 I think is a great problem, which usually means you guys don't like it very much. All right, what's going on in here, guys? We are trying to find h prime of 4, and they've given you a definition right here of h of x. Well, the one big idea I want to make sure everybody understands here is that you can't find h prime of 4, a specific value of the derivative, until you have found h prime of x first. You've got to find your general derivative before you can evaluate it at a specific point. So we've got to find h prime of x, which is the derivative of this function. So this is where 3.3 gets hard. Most people say I can do the product rule if it's just a product rule problem, and I can do the quotient rule if it's just a quotient rule problem. But when you give me something like this, where it's a mess, I get a little bit confused. Okay, here's how we're going to try to attack that. What I see here in h of x is that there's some stuff on the numerator, on the top, some stuff on the bottom, and they are being divided here. That means that overall, h of x is a quotient function, and that means I'm going to need the quotient rule in order to figure out this derivative. So here we go. The quotient rule says we take our denominator, the bottom, multiplied by the derivative of the top first. So my denominator is g of x multiplied by f of x. There's the bottom, multiplied now by the derivative of the numerator. The derivative of x is just 1. So there's bottom times derivative of the top, minus the top, which is x, times the derivative of the bottom. And here's where things get interesting, because in order to find the derivative of the denominator, now let me just block out everything else except this here, guys. The denominator is a product function. So when it's time right now to take the derivative of the denominator, that is going to require the product rule. And the product rule is the first factor, g of x, times the derivative of the second, which is f prime of x. First times derivative of the second, plus the second factor, f of x, multiplied by the derivative of the first factor, g prime of x. Now I'll remind everybody, you can switch the order of these two terms here within the product rule because of the plus sign in the middle. So if anybody preferred to write this as f of x times g prime of x plus g of x times f prime of x, perfectly fine, everybody. However, I want to make sure everybody understands that the quotient rule is not reversible. So what you could not do, although this is a common mistake that I see, is don't do this, guys, is reversing the order of these two terms. You cannot go top times derivative of the bottom minus the bottom times the derivative of the top, because quite simply the subtraction operation is not commutative. So it's important that we get that right. Now wait a minute, I'm not done with the quotient rule. So I did my numerator, bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. So what I'm going to do here, guys, is I tell you what here, I'm going to put in brackets here my denominator, which is g of x multiplied by f of x, and that entire denominator is going to get squared. Now, if the problem was just asking us to find h prime of x, this could be a really difficult problem. If they gave you a definition of g of x and f of x, we'd have a ton of simplification to do here. But actually, guys, it's almost easier. They're not asking us to find the general derivative. They want us to find a specific value of the derivative here, h prime of 4. And that means that everywhere there was a 4 in this entire, everywhere there was an x in this entire expression, we can take it out and replace it with a 4. So the step I'm about to show you right here is probably a step you guys are going to start skipping once you've kind of figured out how to do this. But hey, it's our first one. So I'll go nice and slow with you. G of 4 gets multiplied by f of 4, and that gets multiplied by 1, which I didn't really need to write, but okay. And then minus this x right here is now a 4, and in brackets now, we've got g of 4 times f prime of 4 plus f of 4 times g prime of 4. Whew, almost done. Now in the denominator, that's going to be a g of 4 times f of 4, gotcha, and all of that is going to get squared. Whew, that's a lot going on right there. So I tell you what, guys, let me draw a line right here and then zoom in, but not all the way, because I need to be able to see that table in black up there at the top of the page while I go to fill in all these values underneath. Now you'll notice, guys, the only x value we used in any of these functions is 4, and lucky for us, all of these values right here use an x value of 4. So I think that table is going to tell us everything we need. In fact, I don't just think that, I know that. It would be impossible to do this problem if you needed, for example, a value of g prime of 3. They didn't give it to us, which must mean you don't need it. All right, here we go, guys. G of 4 is the first thing I need, and I read that right here. G of 4 is equal to 5. That gets multiplied by f of 4, which comes right here. That's a value of 10. Okay, sure, times 1. And then minus 4, and in the brackets now, g of 4, we did that already, that's going to be 5, but this one is new. F prime of 4 comes right here. That's a value of negative 2. I'll put that in parentheses. Plus, f of 4 is again 10, and we're multiplying that by g prime of 4, which is negative 1. That takes care of that. And then down in the denominator, g of 4 is 5. That gets multiplied by f of 4, which is 10, and then all of that gets squared. All right, guys, I think now we are done with the table, and I think I can zoom in, and just focus on what we have right here and knock this thing out. Let's take a look at what we got. The 5 times the 10 times the 1 is going to be a 50, minus 4, and I think this is going to take me a step here. We're going to get a negative 10 right there, plus another negative 10. That's going to make a negative 20 in those brackets. And down in the denominator, that's a big number. 5 times 10 is going to be 50, and that's going to get squared. Whew, that's a large number. Let's see if something happens on the top. That's going to be a 50 plus, no, that did not cancel out. Interesting. That's going to be a 50 plus an 80 all over a 2500 down there on the bottom. So we get a weird answer here of 130 over 2500. The only thing I think we can do is cancel a 10 out from each spot, and I end up with this ugly value of 13 over 250.